During any sort of travel, if they say, and when you and your wife are together, they say, "Is there a doctor in the house?" Two hands go up. I want to travel with y'all.
Yeah. Luckily that's never happened. But but I do see the point of it. Yeah.
You know, it's so I didn't have this question here, but you kind of like alluded to it a little bit. And it seems as though conventional or, medicine, the traditional medicine route has a bone to pick with naturopathy, where it's like, and I've heard it also from some of my friends in science, and they're like, well, there's not enough research behind that sphere, within that sphere, behind some of the treatment and treatment modalities and whatnot. But you come from a conventional path, working with the CDC,
Right.
everything you've done. Like, so where's the gap in between these two? Like, why are they so far apart? Because I almost feel like naturopathy should have been the foundation of traditional medicine.
It should have been, because natural medicine been around before conventional medicine. I mean, what did we do when we were out there, miles and miles away? There's no doctors hanging around, and they relied on the land. They relied on folklore. They relied on a lot of stuff. A lot of the stuff is actually works. I mean, we got a lot of our drugs from these folklores or different things. Now, some of them we still don't really understand, but for the most part, there's a truth behind that. But I can kind of shed some light on what happened. What
Please, yeah.
happened was, one of them has to do with money. During a long time ago, they had country doctors. They made their house calls. They did a lot of botanical medicine. That's all they had until pharmaceutical companies came along and started, trying to make money. A lot of it has to do with the acceptance of naturopathic medicine. Naturopathic medicine's been around for a long time, but the research is just catching up. For example, they say if you can do the research, it takes about 10 to 15 years for it to trickle into traditional medicine. And that's not just naturopathic medicine, that's just research in general. And that's ridiculous. I'm a researcher by trade. I love doing research. A lot of the stuff I found, you have conventional doctors, MDs, PhDs doing the research. It's just that they're not introducing it to the mainstream. And if they are going to introduce it, it's going to take a long time. And they look at statistics and the p-values and all this other stuff. Statistics has a major role. I'm not knocking statistics, but sometimes does it work? Is it safe? If it works and it's safe, forget about the statistical part. Just use it. But that's a whole new different ball game. But yeah, that's how naturopathic medicine, I think, it gives us choices. With the research, it gives us better choices. Like, for example, if you had low vitamin D, the doctor says, okay, you need to get out in the sun. We might give you 10 to 50,000 IUs once a week. And then most of the time that doesn't work. And then when it doesn't work, they just keep increasing the dose. And it's like, well, that's not going to work. So how do I get around that? Well, what I do is I says, okay, what other choices do we have? And there are plenty of them. If it's not working, why is not vitamin D not being activated? Because vitamin D we get from the sun, vitamin D that we get from our food, the vitamin D we get from our supplements are not activated. They're not activated yet. And you have to have magnesium, B6, and zinc to activate it. Now, the pituitary gland plays a little role in that when needed. But for the most part, you have those three ingredients to activate vitamin D. Doctors don't recognize it. They'll just keep pushing the envelope. And then they wonder why my vitamin D levels are still low. So I give my patients choices. Here are your choices. If you're going to get out there in the sun and take these vitamin D, you got to add magnesium and zinc and B6 in order to activate it. activate your vitamin D. Because if you don't have it activated, the body goes, if you're not using it, it just stores it in the fat. And when it does that, it looks like you have a vitamin D deficiency. In actuality, you really don't. It just needs to be told what to do.
Mm.
You see?
Mm.
So giving people choices and what they need to do, or giving them better direction, plays a major, major role.
Hey, Doc, this
Yes,
is some
sir.
good stuff. I'm thinking about antibiotics and how when they first started, according to what my elementary research, Egyptians used to put molded bread on wounds as far as like for as an antibiotic, and it seemed like when that voice was small, it didn't seem like it made any sense. Now it seems like it's the other thing. Now antibiotics is the big thing
Right.
and naturopathy is smaller. But explain how those how trends kind of pass back and forth like a baton.
Well, you mean as far as the trends, as far as the antibiotic use?
Yes.
Okay. So the antibiotic use, it came from a time. Okay. So during Dr. Fleming, he's the one that came up with the penicillin. It came up by accident. He's sloppy. He was dirty. He left
Yep.
some bread out. So come find out, he came back. There was a ring, basically this ring where the bacteria had died. He goes, oh, so he investigated, and it was penicillin coming from molded bread. This was a time during the war, World War II. So we didn't have penicillin, but it became like a miracle drug. And when it was a miracle drug, so we found a use for it, a really good use, because people were dying of infections. So over time, it became very popular and became more of not for working with the war effort. It became more of everyday life. If you have a bacterial infection, we're going to give you some penicillin, but other antibiotics. And started looking at other different types of antibiotics and seeing that there was a purpose for them. Come to find out, doctors at that time really didn't know what was going on. So they would give antibiotics for viral infections. Viruses and bacteria are two separate things. They're not the same. So over time, people start requesting, I want antibiotics for this. And doctors were kind of bullied in and pressured into giving them antibiotics when they really didn't need them.
Right.
I'm talking about if you have a small infection, you may not need antibiotic right away, but they push it. Over time, the organisms start becoming resistant because of the exposure. Just because you take it, all of them don't die at the same time. Some of them are going to die. Some of them are going to be crippled a little bit, and then they're going to recover. And the ones that recover kind of learn from that experience. They say, oh, you try to kill me. So I'm going to find different ways. So the trend started to become overexposure to antibiotics, started to create an antimicrobial resistance among bacteria. One thing a lot of people don't know, this is going to sound weird, but bacteria have sex. Yeah, they do. So it's not just about cellular division. It's actually exchanging genetic information with other bacteria. It's called it's like organ. It's a little part of the cell. It's called a pili, and the pili is basically exchanging genetic information back and forth. So let's say, for example, an organism found a way to get around penicillin. That gene is there. That bacteria can pass it on to another bacteria who wasn't resistant before. Now they've accepted the gene. Now they've got a resistance, to that whatever drug that is. Overexposure or not used properly created this big pattern trend of antimicrobial resistance, not only in humans but animals. We were giving when I was at working on that project, we were with USDA. Huge amount of antibiotics being given to cattle or animals to keep them healthy. But when you overexpose them, guess the same pattern happens. Bacteria find a way. We eat it. Sometimes we get infected. The residual effects of the antibiotic is still there. When you eat it, so it doesn't just disappear. So when you eat it, you get bits and pieces of that antibiotic, and if you get an infection, by the bacteria may start building a resistance toward that.
No.
So that's the trend that I've seen happen. The reason why there's this big difference between the two worlds is because of need, and then now becomes we need it, but now we've done so much to it, we kind of abused it, and now we've got a resistancy pattern, among these different bacteria.
And so not just in cattle, but you also mentioned green tea and black tea earlier.
Right. Oh, right. So the green tea and black tea have different compounds that actually inhibit the growth of these well, at least the ones that I was testing. It was E. coli and Salmonella. These are fecal organisms, means they live in your gut. Animals have them too, but I was testing them on human isolates. They were getting from people. That's what I was testing. So they do have different properties, these chemical properties that actually, interfere with the growth of the bacteria.
Sorry.
So we were basically, what I was looking at, that we were looking at killing them. We were looking at basically destroying them. So if you kill them early enough, and if you do it right, you should be able to kill them so they're not coming back and they're not gaining the resistancy. The longer they're still alive, you increase the chances of them possibly becoming resistant due to the overexposure of the antibiotic, or due to the exchanging of that genetic information from another organism.
Mm-hmm.
It's kind of weird. No one talks about no one talks about that, but it was interesting. So you can have green tea or black tea, and there's other different foods that are out there that can disrupt the growth rate of organisms.